Welcome. Glad you're here today for why top broadcasters and video facilities choose openGear's open architecture system. And as you can see, this is going to be a multi-vendor discussion. I've got some great folks on board with me today. I'm Cindy Zulsdorf, and for the next 30-ish minutes or so, you're going to find out why top facilities, including broadcasters, churches, stadiums, corporate video, and more, are using openGear for color management at live events, KVM over IP, native ST2110 IPMX processing for HDR workflows, fiber camera adapters and PTZ extensions, SRT streaming, and more. Sound good? So each of our experts will share about 5 minutes of gold with you, and then we're going to have a QA session at the end. And first, Bill Renopoulos from Ross Video and I are going to get into what's in it for you when you use openGear. Hey, Bill, how you doing?
Hey Cindy, really good. How are you?
I'm good. Happy. So, Bill, let's chat about openGear for just a couple of minutes and share with everybody what it is and what it means to them if they choose to use it. OpenGear, it's an open architecture modular frame system designed by Ross Video and supported by a diverse range of equipment manufacturers, including the OpenGear leader partners that you get to meet with here today. And one of the top pieces of that, as I just mentioned, is that it's open. And the open architecture allows for lots of mixing and matching. Bill, can you speak to the open architecture bit a little bit?
Sure, thanks, Cindy. So one of the challenges in live production is signal processing from different manufacturers often doesn't connect seamlessly. OpenGear changed that. Ross spearheaded a coalition of manufacturers to create an open modular frame system with a unified control platform, which we call dashboard. This standardized approach allows users to mix and match processing cards, as you mentioned, from multiple vendors in a single frame, which enables easy expansion and seamless operation. In addition, openGear offers users the freedom to choose the best solutions for specific performance, functionality, and budget needs. On top of that, you get backward compatibility as the first generation openGear cards remain compatible with today's advanced fourth generation OGX frame. In addition, new processing cards are continually being released, ensuring that your infrastructure adapts to the evolving technology from IP to UHD and beyond, future-proofing investments against changing technology standards. To summarize, we like to say openGear is one frame with endless configurations.
I love that. I love that so much. And openGear's really proven. It's been in the marketplace for quite a number of years, and there are a lot of frames out in the field. Bill.
Well, since its inception in 2016, it's 19 years by my calculation. openGear has been the forefront of innovation and with the continuous introduction of new cards, ensuring users remain aligned. They remain aligned with the latest technology advancements. Over 5,500 frames have been shipped to date. Most are still deployed today in facilities around the world, big and small. And with a growing list of 180 hardware and software partners consistently innovating, what we like to say openGear is setting the industry standard. And this dedication, excellence, and continuous innovation is shown by many prestigious awards we have won, including an Emmy.
Now, with 5,500 frames out in the field and all that Emmy winning, and everybody's using it, some of those frames need to work together. And so the network-based control is a third kind of key differentiator and point about openGear.
Yeah, exactly. So, integrated with a dashboard, intuitive control and monitoring, openGear offers users a user-friendly, streamlined management experience. And with Dashboard's unified interface for all the cards, regardless of manufacturer, managing openGear products is effortless. In addition to that, Dashboard further helps you out operationally and makes things more efficient with remote management capabilities.
So, in conclusion, the key benefits are the open architecture that lets you mix and match from the different manufacturers and bits of equipment that you want to use. best of breed is the end result, of course, because you're choosing what you want. The modularity, the control, the reliability. It's a great setup with openGear. Any
Absolutely.
final thoughts on that, Bill?
Yeah, well, we didn't even talk about reliability and redundancy, right? That's OGX, a fourth generation modular platform. It's built for 24/7 operation. It's backed by a 5-year warranty. Features redundant power and adaptive cooling, making service a snap with zero downtime. And its front loading has hot swappable modules and a passive backplane, which makes maintenance easy and allows for maximum reliability.
That's perfect. I love it. And you might have seen while Bill was chatting, I put the opengear.tv website up. So if you ever want to check that out, you can see modules, information, downloads, everything right there. Thank you, Bill.
Thanks, Cindy.
Next up, we're going to talk about color management for live events. Tim Walker at AJA. Tim,
Hello. Hi, Cindy. Thanks for having me.
glad you're here. Over to you.
All right. Well, hi, guys. I'm Tim Walker. I'm a senior product manager at AJA, and I've got 5 minutes to share with you some stuff about color management and openGear. So we're going to talk about openGear color box for live events. So first thing, you got to get comfortable with the color box itself, which is a new product. We introduced it in 2022, and it's an inline HDR and SDR algorithmic and LUT transform device. It's got a lot of different color processing options built into it. It's got powerful frame capture and recall. It does support pass-through of a lot of ancillary metadata. It's got a test pattern generator. It supports presets. It's got onboard memory and libraries for all the files that you're going to use with it. And it's got an awesome web UI with video preview so you can see what's going on in the box. And it's got an easy to use SDK built on OpenAPI. But what did we do is we took that product and we put it into openGear. AJA is big fans of openGear for all the reasons that Bill said, and that's what our customers rely on. And so we wanted to get this technology in the openGear chassis. So it's got the same exact processing as the standalone box. And so in openGear, it's really targeted for live production, color management applications supporting 4K and Ultra HD and HD workflows. To do that, we've got 12G SDI ins and outs and an HDMI 2.0 output for local monitoring. And it's actually got a loop through output as well, so you can send the input directly back out of it to a recording device if you wanted to. And it's got its own Ethernet port for the web user interface. So some of the integrated color processing that we have in it is a lot. We've got the AJA color pipeline, which has a 3D LUT surrounded by 1D LUTs and 3x3 matrices. We've got MBCU LUTs built in. We've got ACEs built in. We've got licensable options for the BBC HLG LUTs, ColorFront, and Orion Convert. And I can't go into all those in detail today, so I won't. But just know that they're all in there. So, and you can try them before you buy them. So in live production color management, you might have an HDR workflow, and in doing so, you need to make sure that all the signals that are landing on your production switcher are in the same dynamic range and color space. A lot of times it's HLG BT 2020, but your camera sources and other sources feeding it might not be. And this is where you could use the openGear color box as an inline color transform to convert all of those signals. It could be log, it could be SDR, and you can convert it using the OG color box into that HLG BT 2020 production format. And on the output, you have different deliverables that you may need to satisfy. It might be an SDR deliverable, it might be a PQ, and also just an HLG, and the openGear color box can convert it to those other deliverable formats. So looking at the user interface, this brilliant web UI, comes out of the openGear color box and gives you control over all the different color processing and color correction tools within the box. Some people might not want to use the user interface itself and would prefer to have a tactile control surface, which is why I'm showing these here. These are two different companies, Scarhoy and CyanView, who have used the openGear Colorbox API to develop their own native control interface with their control panels. And what this does is it gives people, particularly in live production, who are familiar with having knobs to control an RGB color corrector or proc amp, for example, the handles to be able to do that. So these can control one or many openGear color boxes natively. So here's where I'm going to exit out of my little presentation here for just a second and show you a little bit of a demo. It's got to be brief. So here I'm holding up a Scarhoy control panel, and I've got control over my openGear color box gain, and you can see it in the web UI changing. And then also I've got my HDR image analyzer from AJA showing the waveform there. So it's just that easy. You've got RGB color corrector controls right there on a hardware control surface, and you can see it happening in the UI itself. So pretty powerful. Back to the presentation. You may be wondering, well, Tim, that's awesome that it can do these conversions, but what's the latency through the box? And that's something we kept really tight control over and kept the latency down to less than half of a video line. So it's important for meeting the auto timers on the downstream production switcher, and also just maintaining really low latency. So again, the benefits of openGear: you can fit 10 4K channels in just 2 rack units. You get serviceability and redundant power supplies, and all for a very low price of $19.95 per unit. So it sounds like my timer's up, but AJA does lead the way in HDR and color conversion tools, and the openGear color box is just another one of those tools available to you. And with that, I say thank you for attending, and for more information, please visit aja.com. And you can find more information there. Thank you so much.
That's great, Tim. I loved the real-time demo there. That was so perfect. Folks are using that for live production and live events right now. What type of facilities have you seen that in?
Yeah, we're seeing it starting to gain traction in mobile production trucks, really, where they're trying to do Cine-Live applications, where they're using cinema cameras in a live production environment to create that cinematic look. And that's one of the places where we're seeing the immediate pickup of it.
Thank you so much, Tim. I appreciate it.
You're welcome. Thank you.
Dave Campbell at Apantac is going to talk with us about KVM keyboard video monitor over IP. Dave, how are you doing today?
I'm good. So Apantac was one of the early adopters of openGear, and we've got over 40 different variations of cards. I'm going to share a little presentation. So normally we always build what I call throwdown units, and then if they're successful, we turn them into openGear cards. And KVM over IP is one of those such cards. We can fit 10 cards in a single frame, and they'll support up to UHD 4K. So that means 40 by 96, 4096 by 2160, or 3840 by 2160. They can be copper, or they can do fiber network. Then you can have the throwdown units at various locations. So you can build a matrix essentially with your system. So if you have 10 transmitters in a single rack frame, you can go out and start and build access stations or workstations from different locations in your facility. And you can just keep growing that by adding more transmitters for the computers or more receivers for the workstations. And this is just one of the examples that we've done for a customer. And the other nice thing about KVM is that we can also do video walls up to 8 by 8 that can then take, let's say, one signal over all screens, or multiple sources over multiple screens in any configuration. And then you can just recall them and show your layout on the screen up here. They can be monitored by dashboard. They can be cascaded together with Ethernet, so you can grow your system as large as you want. In this particular case, we had 36 HDMI sources and 9 monitors. We've done systems in production studios that are large as 150 by 150. So in a matrix thing. So some of the benefits that this brings users is that this puts it all into one rack frame, so it gives you a clean solution in the equipment rooms where you might have all your computers. It allows you to grow the network and grow your system, and you can also add other openGear cards in the same frame, so you can use. You don't have to have it all be KVM over IP. Gives you real-time access to computers all over your facility. It allows you to go up to 4K, so you have quality video in all your locations, and it helps streamline your maintenance. So having it all in the openGear frame allows you to one central point of where you can troubleshoot, and you can monitor it through the dashboard, so you can see if boards are there, hot swappable. Don't have to disconnect cables and stuff from the back because the rear panel stays put, and all you do is change the card if you're servicing it. So in applications, we've done stuff in command and control. We've done it in sports applications. We did a big system for the World Cup a couple years ago. We've installed them in OB vans, production studios, small broadcast facilities. Wherever you can think, we can usually help out. So
That's great, Dave. So I loved hearing about all the applications, including the video walls and production studios. And I like your diagram there that shows really how that saves space. And of course, it's bringing you into the IP world with KVM. Nice.
yeah.
So if people want to know more about it, your website, is that the best place to take a look?
Yeah, www.apantac.com, or we'll be in NAB in a couple of weeks at South Lower Hall. We'll definitely have some of these set up and working, and so we look forward to seeing everybody.
That's great, Dave. And we're putting everyone's booth numbers into the chat, so you'll see that information there as well. Also, if you are having fun here, you could think about joining up the openGear My Way tour at NAB. Check for the link in the chat. We've got a tour going at the show, so check it out. Next up, let's talk with Ciro Naranja at Cobalt, and he's going to get into native ST2110 IPMX processing for HDR workflows. Ciro.
Thank you, Cindy. Cobalt's a big supporter of openGear. We were one of the founding companies together with Ross, and we have a very large number of openGear solutions. I'm going to focus today on only one area, but I will show you several openGear cards. I promise I have 3 slides, only one that matters. So this is the one. It's a diagram. It's a full diagram. I'm going to walk you through that. And the nice thing about 2110 is that not only you have your switch is your router, and the big idea here is that you can have a bank of processing elements that are general purpose. So let's start with the signal flow here. You have your sources that can be HDR and SDR, and as the other panelist said, it's best if you bring that to a consistent standard. Normally, you want to produce in HDR. So stuff that's coming into HDR, you want to stay in HDR, maybe change from slog3 to just pure PQ, and stuff that's coming in SDR, you want to bring it up to HDR in a process called inverse tone mapping. People say upconvert, but I cringe a little bit because it's inverse tone mapping, but go with the flow, right? So there's some cameras today that have 2110 outputs, but if you don't, we have a nifty little card, which is an openGear bidirectional gateway. And by the way, everything I'm talking about here supports both 2110 and IPMX. I'll talk about IPMX a bit at the end. So that brings it in. The way it is, doesn't do any processing, just hits the switch. And now the key thing here is you can have a bank of processors. Those are, again, openGear cards. It's our 9904 and 9905 cards with 2110/IPMX interface. So this is a native ST2110 processing element. And so when I say, oh, you need to switch, or you need to use a 3D LUT, or you need to do something with the signal, just ingest it in your 2110 network and route it one of these. How do I route it one of these? Use NMOS. Everything we do supports NMOS, so it's very easy to go to some NMOS controller, there's many available, and just say, this camera here goes to this channel on this processor, and this is what I'm going to do with that. So what can we do with that in the set of cards? By the way, the 9904 UDX is a 4K card with a single 4K, and the 9905 MPX is a quad 3G card. So you have both 4K and 3G capabilities. So what can we do in these cards? We can do 3D LUTs. We can do ITM, which is inverse tone mapping, which is a conversion from SDR to HDR. We can do any custom LUTs. And for that, we have interfacing with LiveGrade and wall, where you can do your LUTs on the fly. It bears talking about this SL-HDR stuff, which is the technical HDR solution, where you have two parts of that. A special version of dynamic ITM, where you convert the SDR to HDR dynamically. No, it's not a static 3D LUT, because let's say it's a sports event, and you start under natural light and goes late and goes at night, and now you have artificial light, the best conversion changes. So we have that. We have a dynamic conversion that gives you the best HDR. And so now you can process it. Not only you can do HDR conversion, HDR processing, but you can also do up-down cross. You can do any sort of color correction with external panels. All of that native on 2110. So I'll hit the switch. You want to watch it? We have a little box for you. What I showed here is a quad channel box that can be mounted behind the monitor, and it just converts the 2110 back to HDMI. We have a single channel, a dual channel, and a quad channel version of these boxes. You need to go back to SDI, use one out of those. It's a quad channel gateway, and it does SDI to 2110 and back. So you need to do SDI. My color code here, see, blue is SDI. You do that. Now, you want to contribute over the internet. We have an encoder for that. And that's the 9992 encoder, Pacific 9992 encoder, for which we also have a 2110 interface. So you need to go out, or out to YouTube, to whatever, or to a private line. You can use the Pacific 9992 encoder, plug directly into your 2110 workflow. And I'm showing two examples here, where one is doing AVC for legacy SDR, and the another one which is doing HEVC for SL-HDR1. The SL-HDR1 uses SMT2108 metadata, and that goes in here and gets inserted. So that gives you a complete solution, right? And what about IPMX? IPMX is 2110 made easy. IPMX is 2110 with, you don't need PTP, and while we require NMOS to make it simple, and there's some other minor differences for signaling, but all the Cobalt 2110 stuff has been updated to IPMX. So if you're in an IPMX network, we got a solution for you as well. So all of that supports the IPMX workflow. So completely native. You don't go to SDI in any place of this workflow. 2110 in, 2110 processing, 2110 out. And the nice thing is this is a bank of processors. It doesn't depend on your wiring. You can be using it today for one thing, tomorrow, or if you need to bring one online for an additional thing, it's all here. You don't have to do cabling. It's all also cable to the switch. So as I promised, it's only one significant slide. So this is only to say thank you, and if you have questions, we'll take them at the end. Back to you, Cindy.
Thank you, Ciro. That was fabulous. All right, we'll just, oh, thank you. You did the stop share. Perfect. Ah, great information. Loved hearing about the ST2110 networks and IPMX and how Cobalt all puts that all together. Super interesting. Any thoughts about where those are being used right now, Ciro?
Oh,
You
yeah,
had that great diagram.
Yeah, I have the diagram is the ultimate thing that you can do. But yes, the sports truck, I don't know if I can say this in public, but the big football events are being done exactly this way. So there's many of these deployed on big trucks that go to sports events. Some that you watch on Thursday, maybe. I don't know. I don't watch football. I should, because we're producing it, right?
That's great. Love it. Perfect application example. And if you want to see more applications, the brand new openGear Ultimate Applications Guide is out. I see that Fallon put the link in the chat. You can pick up a copy for yourself. And if you're watching the replay, we'll have the link there for you as well. Let's go on to fiber camera adapters, PTZ extensions, stadium links. Jesse Foster at MultiDyne. Hello.
Hey there, everybody. Do you see my screen showing a hub and spoke?
It's perfect. Yes.
All right. So essentially, what this presentation is focused on is the convergence of our technology that you'd find in different types of form factors within the openGear chassis, allowing system designers to homogenize the engine room or the truck to be openGear holistically and have the inherent attributes that were referenced earlier, like redundant power, cooling, and remote control and monitoring via dashboard and SNMP where applicable. So we've had a lot of success with large SIs and consultants that's been trickling down to the user base where we have this convergence happening. A quick story, a couple weeks ago, I was up at Meta, and in the machine room, the terminal gear of choice was openGear. There were no other incumbent vendors from previous decades that used to own the industry. It was all openGear, and we were sitting happily next to Cobalt, for example, all within one type of frame system, and it just made it really easy for the system integrator and the end user at the end of the day. So a couple use cases I'll go through quickly. Starting small on the granular side, we have our nano bricks. The nano bricks for digital signage or edit bays, really the range of applications is limitless. But what we're showing here is 40 3G SDIs over 40 fibers. We also do CWDM extensively within the openGear platform, but this is a fiber per application. So this is 40 3Gs in a 2RU frame, and at IBC, we'll have 80 12Gs in a 2RU frame, showing this same concept. So that'll be the density that we'll be able to achieve at IBC timeframe in openGear is 80 12Gs. So on the more sophisticated side of things, where we do mixed signals over one fiber, this is essentially the engine that is employed. So at the most base level, the card is capable of 4 12Gs. They could be uni or bidirectional. I'm showing bidirectional here. And then you see all these constituent components, the signal components that make up, say, a camera system or traditional workflow with teleprompters with CVBS or proper Blackburst sync, tri-level, bi-level sync, time code audio. So it's a very comprehensive card set is employed extensively to really bring the unified Unigear, openGear footprint in the machine room. So the VersaBricks is also known as a VB series. Here it is being versatile in the aspect that it's doing POV and PTZ extension. You can define the remote side to the amount of signals that a camera platform requires and tailor the openGear side to match. So this is deployed up at Google G3, for example, these two camera types with these openGear cards. Here's a VersaBricks in a different application showing, 10, 12 Gs from the machine room over one fiber to a VB box, doing digital signage with HDR support over one fiber with redundant power. Nice and easy, right? So again, you're homogenized to openGear on the machine room side. Shifting over to Silverback, which is one of our more high-profile products that's used in the Super Bowl extensively and so forth. You see up in the upper right-hand corner, openGear is now a choice for your base station types. So now we have 4 different form factors depending on what you're doing. And the granularity scales, if you need audio, this is 3 channels in a 2RU openGear frame with essentially 4-wire intercom, program engineering, and program audio return, excuse me. And then 4x4 audio just for recording on camera or whatever your application is. If you don't need audio, we can get 10 of these cards in a 2RU frame. Now you get some extreme density, and that's basically what's deployed up in Silicon Valley at Meta and Google is high density without audio for the applications. So further into the Silverback side of things, here is a 3-camera chain system in 2RU because we're implying you need audio here. But you see that, everything at the edge is specialty, exactly what you need to solve the problem, homogenized to openGear on the receive side. So one of the big changes we have coming here shortly after NAB will be available is the Honey Badger OG. So Honey Badger initially had a companion 4RU device that you'll see here. It is optimal for XLR connectorization. It has its attributes, but once you're in a machine room, you're going to want to collapse that into openGear frames now that it's available. So system engineers, system designers are really embracing this concept because you get your D25 Tascam pinout audio connectors that you take right into your matrix. You take your intercom right into the matrix. Everything is connectorized and it's on the right side for a machine room application. And then you get your dashboard and cooling and all the other attributes that come along with it. So the convergence statement of openGear, that's what the whole platform's about, is good ideas converging in one like form factor. This is our 2110 solution. We have bidirectional 12G, unidirectional dual on the network, off the network. We can do multi-channel 3G, like 6x2 would be an example that we're showing here in this drawing, which is 6 base station cards doing all the connectivity, gen lock, time code, everything you need back to the cameras, taking those 6 program videos, putting them onto a 2110 network, and taking 2 discrete receive signals off the network and showing them on teleprompters, whatever the application is, all in one card, all in one frame. So that's the beauty of this convergence that we're bringing is the simplicity of command and control over your network. It gives you visibility out to the edge that you have fiber connectivity, that your signals are present. The attributes are really, they stack up when you start doing the math. But that's essentially what I had for today.
Thank you, Jesse. That was great. There's so many examples in there. I'm going to rewatch that segment and review them because everything from the stadiums to Meta to everything that you talked about and how you solved what your customer need. That was amazing.
Thank you.
You can see all of these people at NAB, and I think Fallon and Catherine have popped the booth numbers into the chat, but we'll put that in one more time so you can see everybody at the show. And of course, if you're not going to make it to the show, that's all good. Just reach out to any of these folks and they'll set up a time for you to have your own personal, online NAB or even maybe come to your facility. So reach out to everybody. We've got everyone's contact details so you can connect further. Next up, we are going to be getting into SRT streaming. So Bill Renopoulos at Ross Video. Hey, Bill.
All right, so first we're going to start with a quick summary of the of our openGear portfolio. We basically have a card for pretty much every infrastructure needs. So starting with distribution, we go all the way up to UHD, cover analog and audio. On the conversion side, we do both format, frame rate, as well as SDR, HDR conversion. Our audio mux, demux portfolio covers a wide range from analog, AES, all the way to 12G. Similarly with FrameSync SD to 12 gig SDI, including fiber. Our very popular master control keying and branding card, MC1. We also have bank processing cards, specialized cards for that, and lots of transport cards, fiber, CWDM, and SRT, which I'll be talking about today, and as well as audio processing for loudness, upmix, Dolby, and Nielsen watermarking. So now we're going to cover the OSG 8971 SRT streaming gateway. So this is a 6-channel encoder decoder for SDI to SRT. It's fully bidirectional, so each port can be an output or an input. You have HD and UHD support, up to 6 channels of HD, 2 channels of UHD, or you can have a mix. You don't have to worry about choosing the wrong channels for the mix because we have intelligent bandwidth management that won't allow you to oversubscribe the port. How this works is in dashboard. It won't let you do some certain options, certain mixes. It'll be grayed out, so you won't be able to even select them. So it's really simple. On top of the video streaming channels, you get 8 audio streaming channels per video stream. And in addition to that, you can internally select and remap the audio, but you can also re-embed the audio channels as needed on your outputs and figure out which audio channels you want to select. We also have AVC and HEVC codec support. And here again, you can adjust the bandwidth to balance your quality versus adjust your quality versus your bandwidth needs. And finally, on the decoder side, our outputs are frame synced. Here's an example of how it's used in a point-to-point transport. So in remote production scenarios, including REMI, remote studios, and distributed remote talent. You start from a truck, you get the SDI camera feeds, you feed these across public internet all the way to the facility, and they're fed into, in this case, an Ultrix hyperconverged solution from ROS, but it could be a third-party router in your facility. And similarly, the return feed goes over the internet via SRT or a private link back so you can get the return feed to the truck. Another application is ground-to-cloud transport and cloud-to-ground transport as well. So in this case, you're taking the camera feeds with the 8971 using SRT to get it up in the cloud. We're connecting with a SoftGear streaming gateway in this example, but it could be any SRT gateway. It doesn't have to be the SoftGear one. Actually, our SoftGear streaming gateway converts SRT to NDI, so you can feed your production resources in the cloud for your production. And then via SRT, it goes back to the studio. So the SDI program and preview feeds get to the switcher operator. There's a camera feed that goes back up into the cloud for your production assets, and a return feed that also goes up into the cloud and comes back down for your remote truck. So that's an example of how this 8971 can be used. It's very popular in OB vans, and these are the 2 major use cases. If you'd like more information, if you'd like to see this card in action, actually, it will be shown at NAB. So feel free to stop by our booth and see this card in action. And if you want more information, you can go to www.rossvideo.com and find more details about the card.
Thank you, Bill. That was great. I loved all the ground to cloud, REMI, and applications that you gave. That was wonderful. And so Thank you, everybody. We had a number of questions, and some of them were very product specific and got answered in the chat directly to individuals. And there's a couple really specific questions. So we're going to just take those questions offline and reach out to you individually if you didn't get an answer already. And so thank you, everybody. Come see us at NAB. If you want to do the openGear My Way tour, you'll see the information in the chat on how you can sign up for that. I'll be leading a tour to all the openGear leader partner booths, and then you get specific demos at each of their booths. So it'll be fun. I can't wait to do it. And thank you all. Bye, everybody.
you.
Thank you.
Thanks, everyone.
Thank you, everyone.
Thank you, Cindy. Great webinar.
Yeah. Thank you.